Okay, so quick review about inverse function. So we have function f of h. So the notation of inverse is f inverse of h. Be careful, this one here is not a negative exponent. Okay, don't take that one because it's so wrong. These are not equal 1 over f of h. Okay, so no, this one a bad notation, but doesn't matter. That notation we need to know. Okay, so now what we review the four property, at least four property. So if we have the point A and B on the graph of f, so on the graph inverse have to be B and A. For example, if you see the point 3 and 0 on the graph of the function, this will become 0 and 3. Okay. Second, so that this means what? This means f and g and inverse f inverse reflect over the y-axis. Okay, for example, if I have a point A and B, let's make a point 3 and 0. So if I have the point A and B right here, so A and B here, so the inverse has to be B and A, right? B equal just like look like here 1, so 1 2 3. So the point inverse right here. So imagine if you have the graph look like this. Okay, so look like this. So how to find the inverse? Just using the graph. So you have look like 1 and 0 here, right? Then you change to 0 and 1. So the point inverse reflect to that one. So which one do you reflect to? Oh no, not a y-axis. I'm sorry. That's a part of the lesson. So here the line y equal h here. Okay, this is the line y equal h here. Every point of the original you reflect to the line of y equal h, so you have the inverse point. So this one reflect means you have the right angle and you have the same distance. If you get from here to here, you draw the right angle here and you get the same distance here, then this one has to be the point of reflect to that point. Right, just like you stand here, this is a mirror, you see your image over there. So also here I go like this, then you have the inverse to the line here, and you got this one, and I connect. Okay, I connect like this, and connect like this, and connect like this. So they look like the inverse of that one. So that will probably reflect over the line y equal h. Okay, this one f of the inverse. What else? So the third property you will see we already did in class. So if you put the inverse, okay, if you put the f into f inverse or the opposite, okay, for example, you have f of f inverse of h, we're going to have h, or f inverse of f of h also equal h. Okay, another one. The domain of the inverse equal the range of f. Okay, so because you exchange between x and y, right? So therefore the domain of the inverse equal the range of function f, or the range of the inverse equal the domain of f. Okay, opposite. Okay, so that's what we learned. We already know. Now today I continue to develop more property of the inverse, and we see how we can find the inverse function. Okay, so for example, also we know that in order to find the function, how to test if the graph is a function, you have to draw the vertical line test, right? If you go through only one, so this one not this one the function, right? However, if you draw the horizontal test here, if you don't go through more than one, and this one not the one-to-one function, it is a function and not the one-to-one function. So how it affects the inverse? So take a look at the first example here. So I have f of h equal h squared. So you see the point of h squared on the graph h squared, you well know like this. So you put a whole lot of points, right? So you have x and y. x equals 0, y 0. So I have this point here. Okay, so x is 1, y equals 1. So I got this point here. X equals 2, y equals 4. I got this point here. And finally, x equals 3, y equals 9. So 3, 4, 5, 6, 7, 8, 9. So you connect this one. That is this one, x squared, where x equals positive. So how about when x is equal negative? I use different color. So for some reason, okay, negative. So I got negative 1, y still 1, right? So negative 1 and y equals 1. So I get that point. So then I have negative 2, y equals 4. Negative 2, 1, 2, 3, 4. Then negative 3, y equals 9. So 3, 4, 5, 6, 7, 8, 9. So I got this part here. So this one make a full y equals x squared, right? From the left to right. Now, how to find the inverse? So we know that the inverse, this one y inverse, still x here. Yes, still x here, but this y here not the same y. So here f of x. So this one is f inverse of x. Y equals this. This one y equals that. So how to do it? We just exchange between two of them, right? Then you have 9, negative 3, 4, minus 2, 1, 1 here, minus 1, 0 stay the same, 1 stay the same, 4 and 2, 9 and 3. So now we plot the point. We plot this point here, 1 and 1, the same, they share the same inverse, and the original share this point, 4 and 2, 1, 2, 3, 4, 1, 2. So this one 4 and 2, clearly 4 and 2 reflect to that line. Okay, so how to see it? Reflection here. So we go all the way here. See that? So you see very clear, right? So the reflected line y equals x here, somewhere here. This is the line y equals x here. So the point here reflect to the original point here at 2 and 4. 2 and 4, right? So 3 and 9 become 9 and 3. So 4, 6, 7, 8, 9, 1, 2, 3. So the point here reflect to that point here, like this. So same right angle, same distance here. So then I connect the inverse of this one, right? Okay, so this one is inverse of that range. How about this one? So the inverse of this one is 1 and negative 1. So I have 1 and negative 1. So this one inverse to that point. Then 4 negative 2, 1, 2, 3, 4, 1, 2. So this point here reflect to that point here, okay? Reflect to that point. Finally, 9 and 3, 1, 4, 5, 6, 7, 8, 9, 1, 2, 3. So this one reflect to that point here, go to the line here, and you get the right angle and the same distance. You can see that? So then we draw like this, okay? So this one here, the graph here is the inverse of the graph f of x equals x squared. However, this is not a function. So we do know that if you draw the vertical line here, it cannot get to 2 points, right? So only one. So how to deal with this? So people trying to break x squared into 2 pieces. So we call restriction. So restriction means I don't want this part, or I don't want that part. I use only one part. So if I use only one part, then I have the inverse function, right? So let's say I don't want this part here. So therefore, I don't have this. Therefore, the inverse here is the inverse function. So how to do this? You still given, okay? You say given f of x equal x squared when x is greater than or equal 0. This one is a restriction of the not one-to-one function. You see, these are not one-to-one function. You cannot have inverse function. In this case, you have inverse relation. Okay, this one related to that one, 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 but not a function. So now after you restrict x squared into only half of it by given like this, the condition is x greater than 0. So all the part x negative we remove it. Okay, remove all out. So finally you have only half of the parabola. Okay, you start from greater than 0. Okay, so you start from here, and 1, 2, 3, 4, So this part here is a parabola, and then when you do the inverse, you have the inverse function. Okay, and if you don't like the range, you can actually go greater than 2 if you like. So you start from here, and you start from here, and you restrict function to this, and this one inverse of that one, if you like. But nobody do like you, so you on your own. Okay. Okay. So now we are starting to investigate the inverse of a trigonometric function. Okay, the inverse trigonometric function. We don't want relation. Okay, we don't want it. So now let's start with the sine function. So you have the function. Let me dot not to scale. Okay, we dot 5 points, right? Remember, always you have to dot 5 points for sine, and you go from here to here, from here to here. Okay, so you have 2 pi over 2. Here is negative pi over 2, and negative pi. Remember, sine is odd, right? So because we're going to learn odd function again very soon, next section. So remember the property of odd function. When you have in x equals positive, when you want to do odd function, all you need to do is you reflect to the point of origin. For example, you reflect 0, reflect to itself. This one reflect to this point here. This one reflect to this point here. This one reflect to this point here, and this one reflect to this point here, and this one reflect to this point here, and so on. Okay. So then this point here reflect to this one, and this one reflect to that one. So if you connect all together, so this one here is going to be look like this. So, and if you keep doing that, this one reflect to this, and this one reflect to that, and this one here reflect to this one, and you connect all together, and you have another set, right? So if we keep doing this, and you get that one, and you keep doing this, and you get that one, and keep doing this, and get that one, and finally you put in this and get this one. So finally you have the full inverse. Okay. Okay. So that is the odd function. Now how to find the inverse? Oh no. If you find the inverse, so what kind of function we have here? This is not the one-to-one function, right? So therefore you cannot have an inverse, right? So how? If I plot the point, you see what happened here. If I want to graph the inverse of this one, just using the graph alone, and you see what happened is you have something like this. Graph, you reflect to the line here. So this reflect this one into that one. This one reflect into this one, into this one. So then you go like this. You're going to have like this. Okay, and this one and that one. And finally you go like this, because they reflect like this. This one reflect to that one, and go like this. This one reflect to that one, and this one reflect to that one, and you go down here because this one reflect to that point here, and finally this one going down here. This one reflect to that one. So now this is not a function, right? So now how you restrict this function sine into one-to-one function? So let me reconstruct again the function sine here, where you should restrict this function sine. Take a look. So let me erase the inverse. It's become very confusing. Okay. So from where to where you can turn the function sine into the one-to-one function before the inverse. Okay. Take a look. You want to draw the lattice, right? So from here to is okay. It's not okay because lattice from here to is okay. Because the lattice go to here, you can restrict here, okay? Or from here to here, too short, from here to here. But this one better. This one from here to here because close to 0, so manageable, easier manageable. So we decide to restrict the function sine from here to here, which is from minus pi over 2 to pi over 2. So the rest is we erase this. Just like x squared, right? You restrict x squared from the 0 to infinity. You don't want negative, right? So that is the restriction of the function here to here only. Okay, so this one is sine function between this and this. Okay, this and this. So erase all of them. All right, so this one no. As long as you go down here, you draw the whole horizontal test, right? You cannot have two cross twice, so you have to erase from here. So psi, the inverse of psi. You look at the original graph here, we see for sure it have to be negative 2 over pi to positive pi over 2. Okay, so x is between this and this. So then when you graph the inverse, you're going to have something look like this. The inverse look like this. Okay, so this one reflect to that one. And this one also the inverse function, right? Unlike the last time I draw like this, all over like this, right? So let's restrict into this. Okay, that is function psi. So when you read the book, they give you a lot of information, but you will forget it. That's why you need to graph the function and you recognize from where to where the function become one-to-one. Okay, so the second one is cosine. So the cosine, we start this way, and yes. So also we have 4 points. Let's go 1, 2, 1, 2, 3, 4, and 5. So go like this. This is cosine, 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 and cosine. Now cosine is a even function, therefore reflect to the line y, right? So you reflect like this, you get right here. You reflect this one, you get right here. You reflect this one, you get right here, and you reflect this one, you get right here. So you can do like this, right? And this one reflect to the point right here. So go up here, and this one reflect to the line right here, and you get this here. So that is 2 periods of cosine. Okay, cosine is even. Okay, sine is odd. Sine is odd. Cosine is even. Okay, so now from where to where actually you think the most logical decisions is where from where to where we should restrict cosine. Can be from here to here because not a one-to-one function, right? You see very clear, should be from here to here, right? From 0 to pi. And see that? So we restrict this one because these are not a one-to-one function. If I count this and that together, and if count this together, not one-to-one anymore, so you have to restrict that here. So therefore, cosine is quadrant 1 and quadrant 2. The restriction of cosine is from just quadrant 1 and quadrant 2. So cosine is between 0 and pi over 2. What a big deal. For example, I give you this. I give you sine inverse of 1/2, negative 1/2. Okay, so what is the answer? So take a look at this. You have sine of theta equal negative 1/2, mean this one have to be 210 degrees, right? Right. So this one negative 1 and 2 here, negative 3. Sine theta equal 210 degree. Then sine 210 degree equal negative 1/2. That's correct, right? However, this one outside of the inverse. You know, sine is between negative pi over 2, which is negative pi over 2 to pi, which is in quadrant 4 and quadrant 1. But your answer here is quadrant 3, so this one omit from, not from the domain of the inverse function. Okay? Okay, so the same thing here. If I want to find cosine, let's say cosine of inverse of negative root of 3 over 2. So what is that? The angle is, what is that? So you can say this one equal 120 degree, because cosine of 120 degree here, the 160 reference angle equal negative cosine root 3 over 2 is 210 degree. I'm sorry, 210 degree. Okay, 210 degree like this, cosine negative root of 3 over 2, right? However, this one also the quadrant 3, but we do know the inverse function has to be happening in quadrant 1 and quadrant 2, right? So therefore you have to choose this one here. You choose 150 degree, 150 degree. Cosine 150 degree also equal negative root 3 over 2. Okay, therefore this one here, even you isn't correct, mathematically correct, but this one not correct conceptually because this one outside of the domain. Okay.